Hey everyone, I'm Brad. I'm a principal security specialist with Amazon Web Services public sector team. So what that means in plain English is my team works around the globe with our public sector customers on issues that just deal with security and compliance.
Yeah, and I'm Matt Stainer. I lead security specialists for what we call AWS Industries, and we get the privilege of helping customers that are some of our largest and most complex across the globe achieve their business outcomes with security solutions. And we got a really full packed agenda. So by show of hands, how many people here want to go deep into the academic exercise of just theory? Okay, good. Who wants to actually see pragmatic stuff you can go home and build yourself? All right, these lights are bright. I'm going to assume I see hands. I do see a few. So we're going to jump into it. We got 12 demos today. That's a lot to fit into the time. So kick it off, Brad.
So as a refresher for everybody here, this is a 400 level session. So 400 level sessions are our most technical. Our expectation is you work with Amazon technology, you are familiar with all of our services and acronyms, you know a little bit about programming and code. We're not going to go through how things work. We're going to go quickly through how processes actually build together. One of the things that we wanted to touch on is there's been a lot in AI, right? So you can't throw, an object in town this week and not hit something that says AI. AI-powered slot machine, AI-powered whatever. And so my problem when we started to really see AI emerge in our space and public sector is this is like a big hype train, right? I really personally struggled with how I was actually going to use this in a practical sense. And so what we wanted to do is put together a really good set of tools and techniques that you can use to do this in your role as a security practitioner. So to be super clear, this is a session for nerds by nerds. So if that is not you,
let's hear it for
there's
the
other
nerds.
Great sessions.
We got the nerds out there? Yeah? Okay, good.
All right.
Yep.
Cool.
All right, so let's just start off with a real quick disambiguation. So when the hype train first started to go down the tracks, we had a lot of conversations with customers who were saying their business wanted to build solutions, right? And then how do they secure those Gen AI solutions? So we think of it as a three-legged stool, right? First is how do you secure Gen AI? The second is generative AI for security, and the third is the security challenges that the emergent AI solutions are bringing to us as defenders. Today, we're going to focus on how we use it to achieve our needs and our outcomes. So what is generative AI good for security? So you're going to see these themes throughout the day today. First, we want to automate the mundane, right? We want to take the things that take our time. Security professionals are limited and valuable. Their time is valuable. So what can we do to automate the mundane? We also, again, with limited resources, want to get the most out of our resources, whether these are folks coming out of college, maybe early career or mid-career, or they've transitioned into security roles from development or other tech roles. We want to be able to accelerate that journey. We also want to be proactive. What can we do to help, obviously, when we think about proactive defense? And also, what do we want to do when we want to do analysis in a reactive way? So we're going to cover all those bounds today.
So the one thing that I really want to focus on is that I think it's important for all of you to realize that generative AI and AI as a whole is a tool. And you're going to see repeatedly through our demonstrations and explanations and examples, it's always going to be a part of the solution, is never the solution. And I think if you approach it from that mindset, especially as security practitioners, there's a lot of really powerful stuff that you can do to be a force multiplier for your organization using this.
So here we are, the future's here, right? How many times have you heard that? But this is one of those inflection points where we can maybe think about these tools being the assistant, that virtual assistant that we've wanted all along to help us achieve our outcomes. So there's a few challenges. These are not unique to security use cases, but security practitioners should really think about these. We all know about hallucinations. Kind of fun when you're just playing around, not fun when you're relying on these tools to help you out. Data privacy. We don't want to expose, as security practitioners, we need to be very cautious about what data we're using and exposed to, so we want to protect that. Quality control. How are we building tools and reports and techniques and agentic workloads that we can have quality control. And maybe most importantly, or something to really emphasize, is excessive agency. We don't want to implement confused deputy problems where somebody might get more privilege through an agent-based workflow that these tools provide for us as one example. But just think about the agency these things provide.
So in our first example, I want to go through a use case of generative AI for incident response. One of the things I want to call out on Matt's slide just before is issues around hallucinations or data quality issues. Matt and I didn't want to sugarcoat this for you. So where we run into issues, we're going to show you how things break and what we had to do to actually fix it to get it to do what we wanted to do. So we're not going to just say everything sparkles and rainbows. We're going to try to show you where things don't actually go to plan. So an incident response persona in this case is really going to be someone that is focusing on how do you deal with sort of an organization having a bad day. So your role is really there to respond to that incident. You're going to be using things like runbooks, processes. Oftentimes you're aligning to standards. One of the things that I wanted to touch on is we're going to run through a whole bunch of different services today. And so I think it's important to understand foundationally where those services lie in AWS's generative AI stack. So the bottom layer is infrastructure. So this is raw infrastructure, GPUs, things like AWS Trainium. This is when you're more in the academic side of the model where you're actually playing with sort of bare metal. The next is sort of an abstracted layer, so Bedrock. You're going to see Matt and I use Bedrock pretty extensively in our environment. This is an extension to that foundational model training, so we're basically riding on top of that lower layer. And then the upper layer is where we see things like Amazon Q. So Amazon Q is more relational in nature. It doesn't require you to do anything special. So one of the things that you're going to see in both of our demos is that we both like using different tools. My preference is that I like using SageMaker, and you're going to see that Matt prefers to use Visual Studio IDE. At the end of the day, it's whatever you use, and we just wanted to kind of show you how it looks when you're using two different types of environment. This is taken from work that my team put together. So this is an open source project that we put up on AWS samples. If you don't want to pay attention for the next couple minutes, this is the TLDR. You can scan the QR code and actually go get the notebook. So an incident response notebook is basically going to be using SageMaker to interact with AWS resources. In this case, my shim between the SageMaker notebook and, in my case, Security Hub is going to be Bodo 3. So Bodo is going to interact with Security Hub to get me information about findings, and then I'm going to use Bedrock to help me synthesize and make things make sense. One of the things that I think is really important for you all to understand, though, is anytime you work with any of these AI models, there has to be this question, especially in incident response, of is it consistent? One of the things that we really like for this pattern is this gives you the ability to create a runbook that will work basically anywhere and requires little to no updating and maintaining. But there's that question of, is it going to give me the same answer every single time I run it? So the reason my demo continues to run over and over and over again is that when you define your model parameters, you're going to see that I'm always using a low temperature. So in my case, it's going to be temperature 0. Basically, what this does is it prevents a more randomized response. And again, an example of using what you're going to see with a higher temperature and a little bit more wackiness is that you can definitely assume that this is a little bit more unprofessional, and that's certainly not what I want during an incident response scenario. And so this is really just coming down to making sure those parameters are properly tuned. Here's the key takeaway. Remember that all language models are non-deterministic. So you always have to have in the back of your mind that this is not the same as hard coding a script or a function. The answers are always going to have that possibility of something different comes out because, again, it's a non-deterministic model. In my prompt, what we're going to be looking at is I'm saying that I'm a security engineer looking to improve our security posture. I'm going to summarize our findings and basically give me information. So logically, why would you do this? Like, what's the purpose of this? And really, this kind of comes down to that quadrant that we were looking at a minute ago. One is the automation of the mundane. So I want to be able to summarize threat intelligence. I want to be able to do things like alert correlation. But if you are a 3-letter agency, if you are Amazon, we are all fighting for a very small pool of highly qualified, talented individuals. And so I want to make sure that for the folks that I have, I'm using them for the most good of our organization. And nobody here likes taking tickets, or I assume nobody here likes taking tickets. On the automation side, sort of in the lower quadrant, from a proactive perspective, we have things like patching, anomalous configurations, writing and running playbooks. So that's going to be looking more at what we want to be able to do right now. And then things like threat hunted and guided remediation. And we'll see that in one of my other examples. So first example, so this is Amazon SageMaker Incident Response. This is Security Hub. Basically, I'm proving to you that I actually have this real finding. So in this case, I've identified an EC2 instance that has a security group that's attached to it that is not what I want it to do. The first thing that I'm going to be doing basically is trying to get that Security Hub finding. So I'm executing the SageMaker notebook and saying, give me that finding information. And what do I get back? This big wall of text, JSON, right? So that's not helpful, and if I'm a new hire, that's certainly not helpful, right? So what this next part is going to do is basically use that library to distill all that information for me with that prompt that I showed you earlier, and basically try to help me understand, like, what is this telling me? Like, why does it say that that security group is open? What does that mean? And so here you can see we get this nice, readable human component. It's got information about the security group. It's telling me about, like, why it's not a good practice. So this is a good way to basically help that junior programmer come up in skill a little bit faster. So the next thing is, we've identified that we've got a problem. I really would prefer that it gets fixed. So here you can see I'm replacing that security group ID with it, and I'm basically saying, give me code to fix this thing. And so voila, we now have our Python code, but in this environment, I also have it giving me a little bit of information. Again, my assumption is that this responder is new, so I don't want them to just click something. I want them to read and understand what that function is supposed to do. And in the last portion, I want to do a quick test to say, hey, before I start fiddling with this, is this attached to anything? So I've got a quick sanity check to say, hey, is this actually live? Is it attached to an ENI? So in this case, we can see that the first one's not currently actively being used by an ENI. The second one, basically, we've got 2 security groups that came back in the finding. Is the other one currently attached to an ENI? This one comes back and says that this isn't attached, and so we're good to go on that front. So what I want to be able to do now is basically take that information and move forward to be able to give me a remediation script or function. So here you can see I execute our function to give me back the security group IDs and basically make sure that everything's working the way I expect it to. And then the last portion here is I've got my finding information for that EC2 instance, and we're getting everything back. So the next example that we wanted to run you through is doing the work that nobody wants to do. I'm in public sector. We do a lot of compliance stuff. I actually like compliance, but not everybody does, right? So compliance is hard for a lot of folks. And one of the things that we wanted to be able to do is talk to that persona in the audience that is looking for help with audits, looking to help from a compliance risk persona perspective. So this is who we think you are, and this is the outcomes that we think that you would be looking for in this type of solution. In the US federal space, there are a number of requirements that are emerging that talk about things like software bill of material, or SBOM. And so what I want to be able to do is reduce the operational friction to meet my requirements to generate software bills of material. So in this environment, again, I'm going to be using SageMaker for mine. I'm going to interface again, same like I did last time with Bodo3. And what I'm going to be using basically is that hook to get information, in my case from Systems Manager, to tell me about what's currently in the environment. So our process overview is we, again, are using a prompt like you're a cloud compliance specialist, and this is going to be a FedRAMP-based workload. And what I want to be able to do is to generate the appendix for an SSP SBOM appendix record. So this isn't super complicated to do with raw data. So if we just take the raw information by default, this is kind of what it looks like. We've got a return JSON blob. You can do a basic table transform, but it's kind of ugly, and it also makes things really challenging from a programmatic analysis perspective. So there's emerging standards out there. I grabbed one of them that is getting a little bit more traction right now, Cyclone DX. So what I did is I brought the Cyclone DX schema into my environment so that I could basically say, apply this pattern to my data and then give me the answer. So in my case, again, we've got our SageMaker notebook, and I've got this blob of text at the bottom, right? So I'm a compliance person. I'm not a programmer. I'm not someone that knows maybe what any of this stuff means. So this is my sad face, right? I don't really want to deal with this. I'm told that I need to generate that software bill of materials. So can you make this easier for me? Yes. So in this case, basically what we're going to do is, again, call to that first finding data. So here we can see, again, I'm running that SageMaker notebook. I'm going to load my data. And anytime you see the screen flash, I'm accelerating for time so you guys don't have to watch everything load. So we got that same finding that you guys saw just a second ago. The second portion basically is saying, OK, hey, for that standard that I just brought in, give me the output in that Cyclone DX output. And voila. Now I've got an output.
Did you have to train or fine-tune the Cyclone DX stuff?
Yeah, so no. Basically, this is a really low friction way of basically saying, hey, for this thing, output this type of model, right? And so this helps us to basically move quickly with very little supporting information. The other thing that I often see is people are looking for help with compliance questions. So when you deal with standards, there's this sort of like policy wonk language of you need to be able to apply AC3 controls to subsection 2 and make sure that you're applying to 171 controls that also map to like people that don't do compliance. It's just like, I'm not doing this, or I'm really not interested, right? So what I want to be able to do is I want to take that operational burden off my compliance officer to answer these types of basic questions. And so what I want to do is basically help them. So what's in the box, right?
Nice
so
job,
in this case, I'm preloading my environment with FedRAMP data. So you can see that I've got a copy of NIST 853 R5 in there. I went ahead and actually brought in Amazon's actual services and scope page, like dragged in the HTML page, because why not? I want to know if it's actually in scope or not. And then I also brought in a couple other pieces of metadata to help me understand supporting requirements for my organization. So same process as last time. Now we're going to be doing a more RAG type model where I'm using that knowledge base to basically help me answer questions about that particular data set. So in this example, we're going to go through and try to answer questions to do it. Now, there is an easy way to do this. I'm not going to lie. Instead of going through the SageMaker stop thing, there's actually a UI in Bedrock that actually does this. So this is an example of basically using the Bedrock UI for the knowledge base. You can see that I can answer and ask basic questions. What page is this AC3 control in for 853? It comes back and it says it's on this particular page. I get my source details to kind of verify that it's actually saying the correct thing. But Matt and I said that we didn't want to lie to you, right? So in this case, what I want you to understand is that it told me that it was on a particular page, but this is that human problem of there's a difference between page number and page number, right? So the indicated page versus the actual scroll page, right? So it doesn't understand that context. So in this case, basically, again, same thing. I've got my subset of data, and I'm going to do the same model now with SageMaker. So I want to be able to take that same information and basically get me my output. I ask the same basic question. What controls for NIST 853 talk about encryption? We get back SC28, and it gives me that same handy summary. So if you don't want to use the knowledge user interface, you can see that you can do it really low friction in a SageMaker environment. The difference is that a knowledge worker is probably going to be a lot happier in the console than using it in a SageMaker notebook. But if you're doing this as part of, like, again, an IR processy workbook or a workbook that is specifically being tailor-built to that type of persona, it may make more sense to do it this way for them.
All right, as we mentioned earlier, we wanted to show a bunch of different ways to approach these problems using different tools. We could have chosen a monolithic way to do this. So what we're going to do in this example is find that proverbial assistant that we've been longing for. Our time is valuable. We want to be solving hard new problems as they emerge. And so in this case, we're going to see how these virtual assistants can help us. So in this case, we're going to look at the persona of a security incident responder or someone doing threat hunting. And we're going to use the IDE here in Visual Studio Code and look at an example of how I might be able to very quickly, maybe you're going through a security event or incident, and you want to say, hey, I'm looking for potential misconfigurations in my environment. Maybe I am junior. Maybe I don't know how to write against SEC403, API or SDK. This can help me do this. So I'm using plain English language, maybe pseudocode, and I'm saying, hey, I need a script that can go out and find quad zero or open security group rules. I know that those are not what I necessarily want. They're not compliant, but help me find those across my entire estate, across all my regions, across all my accounts. The first thing here, to our point earlier, it doesn't always work right out of the box. Sometimes this is a conversation. We try not to humanize our chatbots too much, but sometimes you can think of that back and forth conversation. This actually did not configure my default region, which I intentionally set up so I didn't have that in my environment variables, just to say, hey, this gave me an error. I don't really understand this error. Why did this happen? It comes back, it says, oh, you're right. I can see why that error would have occurred. Let me make these adaptations to the script, and let's run it again. So now, in this next one, you can see, I didn't tell it the format for this output. It came up with this. It said, if I'm going to output this to the console, this might be a good way to do it. And you can see it did find some security groups, but now I want to be a little bit more robust. I want to go and say, okay, I want a specific warning message if one's found. I also want it to go output to a TXT file. I also want it to go to a CSV file so I can import it. I want it to put things in the proper UTC format so that I can normalize these with other log analyses. And I'll run it one more time here. And now you can start to see, again, it's doing the discovery of all these. I'll pop open the TXT file as well as the CSV file just to show you what it did on its own. Again, I did not mandate exactly how to do this. I just said these are the columns, or this is what I would like it to return, and it did it for me. And again, it took the output that it put to the console as well as to this raw text file. Here you can see the specific warning message I said I wanted to see if it found one. So I found my non-compliant security groups. I have a Bastion security group. And what I want to do is find where I have that Bastion security group in regions where it's not configured correctly to actually resolve this. Now, we talked about excessive agency. Be very careful when you get into your agentic workflows where you're automating things that make changes to the environment. Obviously, any of this you should be testing. Do not blindly accept the output of these things, especially if it's could make changes to your environment. If it's read-only, assess appropriately. But this one, I want to do human in the loop, right? So I've actually put quite an extensive prompt here. Again, pseudocode, natural language, though. Copying this in, pasting it in, saving it. Let's run it, see what we get. All right. So it is scanning all my regions and not finding anything in these particular regions. And it'll get down to, I believe, US East 1. And that is where we will start to see the findings come up. And what it'll do is, I also said I wanted this in an OCSF format. So just like we talked about with the Cyclone DX, I just said, can you please put it in this format in case I want to pull that into something like Security Lake? And then it gives me a prompt. Do I want to make this change? Yes, no, right? Really important from the standpoint of making sure that this is not doing something without my explicit authorized approval to do so. And now I can go in here and I can see that security group has now changed. It's now my Bastion host security group. So I am now back to my compliance in that region.
So I think one of the things that I'll share as an anecdote is what you're seeing here is the ability to take something that Matt's a smart guy. Like, he could eventually code all this stuff, but how long did it take him, right? Like, it really doesn't take that long to do this, and so that's the whole point of it's force multiplier. It's going to get you to an answer a little bit faster, and it also allows you to put in standards and other things that make that process a little easier. Funny story. I was working with a government customer, and they had a consultant on the line, and basically the consultant was saying that to do this thing that we need to do, this check that we need to perform, it's going to take us probably 3 months to get people together, and we'll have to test the function. And the line went like quiet for like 30 seconds. And this was right at the point where Bedrock launched. And he got back on the call and he's just like, I just sent it to Bedrock. Like, here's the code that you guys need to run. I already ran it for you. Here's the answer, right? So there is a little bit of a mic drop there, but it's one of those things where this reduces that friction of this was like a C-suite person. Like, he just knew how to ask the question. He didn't know how to write the code.
Right, yeah. And that, so those were real-time videos, right? I don't believe I accelerated or cut much in those specific examples. I do in some of the later ones. And that ability to accelerate, again, I could have wrote that maybe, I was about 125 lines. Write it, test it, back and forth, a couple hours of my day, or 3 minutes. Which would you rather do, right? All right, so this one, let me go back a slide here. This one is, again, an example where actually, this prompt is my full prompt. I went back and forth multiple times because I wasn't getting the output I wanted, and I was learning, almost teaching myself, training myself, if you will, how to maybe get the right output from my prompts based on this. And one of the example here I've highlighted in the orange or yellow, whatever color I guess that technically is it kept making assumptions when I just said, hey, can you query inspector, that maybe I wanted the inspector classic API. I don't. I want the Inspector 2 API. So I was more explicit about that to avoid potential errors. This one, I kept getting the wrong calculation. So I would get a return on it's been X number of day, or the date that it was found, and I wanted to calculate that in a number of days. And so I got more and more explicit in how I wanted this to do that calculation on my behalf. And so this is going to go out, and it's going to find within Inspector the vulnerabilities that are in the system. There is a little bit of acceleration here where I've sped it up. So again, that was probably 20 seconds for it to return the response. Just like before, I'm putting it in there. You can see about 120 lines of code. Save, run. So you can see it's not pre-canned. Sped up just a little bit there. Again, an error. What is this particular error telling me? I don't know. Let me ask Q to tell me what this error is actually resulting from. So again, just plain English, copy and paste that error. It's like, okay, yeah, we actually need to address this in a different manner because the findings here, that is not the way that we need to do it. And then it explains what the changes are. So it's not just blindly accepting, it's trying to actually train the trainer or train the coder, if you will, too. So like run it again. This time we see, I think, over 4,000 or so vulnerabilities. I'm a security professional. I like patch hygiene. This is a demo environment. We keep it intentionally vulnerable for this purpose. So trust me when I say. Yeah. So now I've got this output, and the nice thing about this is pretty dang close. But I see a lot of NAs, and what I wanted it to do was extract the actual CVE ID, so I could go to the NVD database link and create a link. Again, that context of extrapolating from something to create something new without having to be very explicit in my instructions. So I say, hey, I'm not getting a CVE ID back. It's just coming back NA. Something must be wrong. Again, it's like, okay, I can see where maybe this isn't outputting what you asked me or expected me to do. Let's try this. So I'll just take the changes, save over it, run it one more time real quick. And this will pop out a result where you will see the CVE ID there, as well as now the NVD link, so I can go out and explore, learn more. What does this vulnerability mean? What's the CVSS scores associated with it? And what do I do to potentially remediate this vulnerability? Imagine, again, you're a threat hunter. You're an incident responder. You don't have time maybe to write a tool that takes hours or days. You want answers as soon as possible. And this is ultimately what we're able to achieve here with these quick turnarounds. So the next series of examples that I want to show is, this is maybe what I'll call the most basic, but sometimes we need basic answers, right? We want to protect our time as well. When you have centralized security teams, a lot of times when development organization, asset owners say, I need a compliance question, their first instinct is, let me ping my friendly security professional. We don't have time to answer all these 100, 200 level questions all the time. What we need to do is make sure we're pointing them to things that are well documented already. And so, too many requests. We have too many requests that come our way. We need to manage our time wisely. So we have this, and it's a bad customer experience, internal customer experience. It's like going to the bank and waiting for the teller. This is something that ultimately, do you really need to stand in line to make a withdrawal or make a basic transaction, right? We don't need to do that. We want to get to self-service. We want to get to that ATM level of capability where they know where to get the answer from, and then they can come to you with the tougher questions and enablement questions. So this time the persona is not a security practitioner. It's the developer. It's somebody in the organization that is what we would think of as a non-security practitioner. And we're going to build, if the last ones were featuring Amazon Q Developer, this is Amazon Q Business. You could also do things with knowledge bases and Bedrock. Again, multiple ways to approach this, but this is a high-level architecture of the components there. The key here is that we're going to have internal policy documents that are going to be ingested into the native retriever, as well as the web experience that comes with Q Business that you can just build on top of. It also integrates with Identity Center, and your identity can pass through. So contextual retrieval of data and information is something you can build. So very powerful and very simple. So like all good security practitioners, we're going to have this login. As I said, this kind of comes with the out-of-the-box functionality. I don't have to think about how do I do my identity. I just essentially expose this.
Oh, it uses MFA.
Oh, man, it'd be a sin if I didn't. No judging. Well, maybe just private judging. All right, so we're going to log in. And again, this is logging in as me, as my identity context. But in this demo, I'm just a developer. I'm not a security practitioner. Let's start with a basic question. Password question. How long does my password have to be? Okay, this should be not too tough. So what we see here is it says, in quotes, we require a minimum of 12 characters in all work-related passwords. Hallucinations, one of the things we talked about, we want to be careful of. We do not want to hallucinate policy. So not only did it quote, and you can see it matches the exact wording there, it also gives a footnote to the direct source so people can validate. And then they also know, okay, well, this is where the source is. Hopefully, if that question comes up again, they are now directed or they know where to go find this information. Okay, let's use a little bit of logic because these tools are getting better at this kind of answering these kind of questions. Can I use a 5-character password? No, because you have to use at least a minimum of a 12-character password. Now, let's say I need to access a database and I'm basically saying how do I manage my credentials there. Is that a password policy question? Because it's a password question. Well, this is smart enough to say, well, actually, there's a database credential policy. And in that policy, it talks specifically about how to store those credentials. So it is contextually aware, based on the context of the question, which source might be the more optimal source. And in the next example, what if your question spans multiple sources? So what kind of encryption protocols are available to use? Friends don't let friends roll their own crypto. So let's provide that for people to use and point them to the right direction. Now we have multiple policies in this case that talk about the appropriate cryptographic policy or cryptographic solutions and protocols that can be used. And you can see now there's 2 footnotes there, 2 different policies that is pulling from. And now I want to ask a question, because we all know how awesomely secure DES is, right? Can I use DES? Again, I'm a developer, I don't know. Can I use DES?
Sounds cool.
It sounds super cool, straight out of 1980. So no, you can't use DES. Why can't you use DES? Because it's not explicitly mentioned in the policy, right? If it's not in the policy, we're not going to allow it in this case. And again, we can go back and we can see the exact source that that comes from. This is very powerful to enable those questions be directed without having to take up the time of your most valuable security resources.
Groovy.
And this is one I'm super excited about. Take it away, Brad.
So this one's going to be a little bit more controversial. So this is going to be using this as a deception platform. So we've been talking about things so far that have been on the defensive side. Now we're going to go a little bit into the offensive side, right? So this is an emerging space. So it's really important to understand that there's still a lot of research that's taking place here, and I want to be super clear. This is an area that could be dangerous. So we are going to be using these models to basically start to respond to an actor based on what the actor is telling me, based on characteristics about the actor, based on metadata that I can tell about what the actor is looking for. But let's, again, be super, super clear on this one. This is a dangerous space. So this is something where you want to take explicit care and focus. Please do not deploy this in your production account next to your crown jewels data. This is something that needs to be in a separate environment. So, deception. This is now moving into that threat hunter / blue team type environment. So the highlighting on this one is the important part in the lower right-hand quadrant. You better have a strong risk appetite to do this because this is an area, again, where we can expose ourselves to risk. So let's take a walk back in time and think about how did we do this before this? So historically, when people want to better understand the capabilities of an adversary, we deploy a honeypot, right? So in the old days, it was physical servers or virtual servers that were out on the network, usually deployed with some type of vulnerability. And the idea was, I want an actor to go and log into that thing and then show me what they're doing. I want to see if they're able to identify things inside of our network. So I'll deploy a honeypot behind the firewall so that I get that early warning. But in Amazon, what we saw customers do fairly early on is customers started to figure out that, well, there's this STS service. I use it to get credentials. I wonder if I can use it to make fake credentials. And so what we saw was the concept of a honey token. And so honey tokens, this is an example of one of a lot of open source projects that did this. And the idea is that basically this tool would generate synthetic tokens that could be sprinkled somewhere in your environment. So I could put it in code, I could put it somewhere in an S3 bucket, and the idea is that when an adversary goes to use the token, I get the trip, basically. It's a tripwire. So the token itself has no permissions or policies, but as an actor, I don't know that until I use it. So basically, as a bad person, I'm going to load the token, and I'm going to say, STS get caller information, I don't know, can I see all the EC2 instances, right? Can I do an EC2 LS? And it'll come back and it'll fail. But the fact that I invoked an API on my side, the fact I invoked any API, will immediately alert me to this token has been used by this resource. The challenge is that this is based on a model that is passive in nature, right? So you've basically got to sit back and wait for the actor to use the tokens. And then there's that sort of question that should be in the back of your head of, are they not using them because they aren't in our environment? Or are they not using them because they figured out that there's a high risk to using these types of tokens, right?
And Brad, I'm just a little offended. You got this picture of me and you didn't ask my permission to put it in the deck.
I'm sorry.
But, you know.
So the challenge here is that, again, it's passive, right? So what I want is I want something that's a little bit more active. So these examples that I'm going to show you are going to be looking at a high-level workflow of things that we do in the real world with real types of customers. I'm going to stay high level on a little bit of some of the background processes for obvious reasons. So you're going to see some of the examples are a little bit simple in terms of how I'm returning the output. That's not because I don't love you all. That's because I want to keep my job. So we're going to be looking at a couple examples basically to show you how to do this, but I'm not going to give you the full code. So one of the things that is important in this space is that in contrast to traditional deception platforms, you basically had to guess who your actor was. So I had to basically figure out this named entity, this insider is who I'm going to go for, and this is how I'm going to try to entice them. In contrast, when we use this type of model, I can start to take attributes about the caller and start to make it tailor-made to them. So I can notice that, for example, that you're using a foreign language keyboard. The probability of that suggests that you have these characteristics about you, and I can start to put things in my responses that maybe would entice you. So you could certainly imagine if I was a multinational defense contractor and I wanted to see if a particular named entity was looking for a particular program, I could try to use this technique in a very tailored way. So the first example is going to be feed the bear. What we're going to be doing is we're going to be synthesizing a shift in real traffic that went to a CloudFront distribution. This is the first hand wave. I'm going to hand wave a little bit and say, part of the process is I did something in the background to identify that this is a malign or malicious actor. And in this case, I found that this was a bad actor. And so what I've done is I've basically used a lambda@edge function to rewrite the headers for that connection. And I'm going to be shifting them over to a separate API gateway that I'm going to be using to interact with this individual. So the API gateway is going to allow me to tie into Bedrock. It's also going to allow me to feed them data. In my case, it's going to be coming from a DynamoDB table. So our first function prompt. I am synthesizing here that I am a student information system provider. And so I want to generate fake student records for this particular adversary. And so basically, this is the schema that I want it to use. And so basically, I'm saying this is the letter grading scoring. This is the sort of bracketing around it. So let's dive into it. Example 5, revenge of the AI. So in this case, what we're going to start with basically is, again, we've got that signal from our actor. And again, I'm using SageMaker. So this is me basically processing, proving that I have a real record that's here. So I've got my hacker1234 record. This is the API that we're going to be hooking into a Lambda function. And so the first thing that I'm going to basically do is I'm going to send a piece of threat information, a threat probe, to the system. And I'm going to use that basically to generate on-the-fly resources. So in this case, you saw the prompt that I used earlier. That's that first part of how it's building it. And we're going to send that through and basically say this is what they tried to go after. And we're getting back, OK, so now I've got my API with my hacker123 record, right? So hacker123 really exists. So now I feel confident. This isn't a honeypot. This is what I want. But the problem is that I need to start making a lot more of these things. So in comes little Bobby Tables.
Or Bobby.
Bobby Tables is going to be our first scanner. So Bobby's going to go, and basically I'm going to start creating records for Bobby. So now he's figured out that this is a real live system. Bobby is a real person I want to find more information about. Well, that looks believable. So on the fly, in the back end, it started creating synthetic information about Bobby. And this allows me to start to tailor based on what that individual starts to look for. So I can infer information about what type of persona Bobby Tables would have been. And then I can start also generating other likely targets that the actor might be interested in. The important part here is that the Dynamo table. What was the purpose of the Dynamo table? Well, remember that I told you at the beginning, this is non-deterministic. So it would be pretty obvious if he said, show me Bobby again. And it gave a completely different record, right? So when we generate the record, I need to put it somewhere so that I can basically recall it for this particular actor. So the reason the Dynamo table is there is I'm dropping this record in there so that if the actor calls for Bobby Tables again, it's going to go and give us the correct prompt. So that's using just basic Lambda behind the scenes to quickly generate the response and give me the information. That works really well when you have a simple code problem, but in this example, I want to be able to do a just-in-time build using a Dockerized environment. So in this case, basically, I'm going to be following the same type of pattern as before, only this time we're going to change it up just a little bit. What you could do is you could do something like an application load balancer to a Lambda function, and then we could also have PCAP tie that could be dumping information to, for example, an EC2 instance. So what we're going to be looking at a little bit more here is how that probe is coming up. So you'll see in my case, the probe is going to be looking for an actor that's now going to be passing a username and password. So this is an example of a blog that we have up that talks about Amazon's threat intelligence team. The idea here is that however you're getting your threat information, this is an example of the type of information that's going to be feeding my system. So it's going to give me information about what path that they were going after and what type of payload they were passing so that I can use that to generate my response. So this one's going to be server on demand. So I want to be able to generate my server. Again, I'm going to be using that SageMaker environment. So this one's a little longer. So the reason that that's such a big block of code is that I need to be able to have basic Docker information in there. So you can see that I'm passing the probe data, but this would be a variable normally. And you can see that my prompt is a little bit more verbose. To Matt's point, trial and error, I figured out pretty quickly that it would sometimes spit out code that wasn't relevant. So here it executes, and it actually generates on the fly an API gateway. You can see that when we go into our API gateway list and refresh, magically there's another API gateway. And now we've got a Lambda function that's in the background. Lambda function executes code inside of the Dockerized container. So this is helping me basically to create that resource again on the fly. So here I'm going to replace the output of my API gateway just to be able to synthetically test this. So the first one that we're going to try is our Bob user. Bob user doesn't exist, so I'm going to get a failed login prompt. I know that the actor's looking for admin, so I want to be able to return back a response that represents what they're looking for when they're getting admin. So this is an example of hand-waving a little bit, right? So I'm returning with a hello world. In the real world, you're probably going to be returning with something else. But in this case, based on metadata that I had about the user and the fact that the payload that they sent to us included that name, I want to give them that name inside of our environment. So the question that you might be asking yourself is, well, he did it twice now. Why did he use Lambda? Time. Lambda is far and away the fastest way that I can do this because this allows me basically to, on the fly, generate resources. And because of the nature of how Lambda can basically be invoked near instantaneously, I can dump code or dump containers now into a Lambda function, which allows me to execute much, much faster than if I had to go build an EC2 instance, go launch the instance, wait for it to come up, attach the instance, right? Versus using the Lambda function, it'll be up in just a couple seconds.
Think about that. If you're a threat actor that is trying to scan and discover, how fast are they moving potentially at that pace that you are now taking that data in real time or as near real time as possible to try to create something before they get to that something, right? You want to give them that feed the bear output. So the timing is really important in building the architecture around that is really important.
So the other thing that's important to call out is, again, want to stress, this is super dangerous. You're doing things that are actually allowing them to interact with your systems. The other reason I like Lambda is because from an attack surface persistence perspective, there isn't. Once the function basically terminates, I don't have to worry about the actor having long-term persistence on, for example, an EC2 instance. It basically will terminate based when the Lambda function actually kills itself.
Probably important to think about the cost implications of that too.
So this is an extension. So again, just-in-time containers building out. So following a similar process, but now I want to be able to extend that a little bit and publish the container into an ECR repository. So again, same thing. I'm passing information based on our threat actor probe, and we'll go in and make some containers. So same process, a little bit longer. We're going to go through, again, same thing. This is our probe data that the actor is looking for. And this time, basically, I'm generating the same type of Python code a few moments later. The Docker manifest is actually now fully built. We're going to publish that into our ECR repository. You can see the API gateway is live. We can see now that we've got our vulnerable application that's actually now listed in ECR. And now I can hook that into my function And now I've got code running inside of a Docker container on that resource. I'm going to grab my API output just to make sure that this is actually working the way I want it to. So again, pointing live to that output. Let's switch to our favorite actor, Bob. We should expect that Bob's not going to return anything because the payload they're looking for is admin. Again, failed. Let's go back and start looking for who I'm looking for, admin. And admin returns again, right? So in this case, why? Why are you moving it to this way? I'm loading code into the Docker container because sometimes you want to be able to do things that candidly are going to be challenging to do as a single monolithic Lambda function. It may take too long to invoke the function. It may take too much space to put it into there. So putting it into a Dockerized container allows me to do things like pre-stage containers to accelerate this process. Everything is about time. This has the trade-off of the few moments later was about 15 seconds. So it took about 15 seconds to fully compile the container, publish it into ECR, and then bring it into the resource. Depending on how sophisticated the actor is and the type of probe they're using, 15 seconds might not be a fast enough response, right? And so this could be something where we're chaining this into a workflow based on other signals information to guess what they're about to do next. So I'm 100% positive that someone right now is saying, that's not realistic. Do it better. So far, the examples that I've been giving you have been really focused on sort of, OK, so they're passing a payload like admin. He's passing a payload that's pretty clear. Like, this is not blowing my socks off. Like, anybody could figure this stuff out, right? By the way, like, come on. No?
That's definitely a double entendre.
So now here's probe data. I have no idea what this, I actually do, but like I'm as a security person, right? Like I got this payload for my threat actor probe, but now this is a lot less clear on what it is that they're doing. So I want to start to shim into this logic. What is it exactly that they're doing? So in this case, I'm going to be using a similar workflow. So again, we can see that we've got the same path and payload before, but what I'm going to be doing is basically saying for this vulnerability, I first need you to tell me what the vulnerability is. So I need you to reach out and get me a CVE for that resource, because that's going to be helpful in developing my prompt. And then I need you to get me more information about the type of vulnerability. So here you can see when I fed it that threat actor probe, it came back and it said, this looks like it's this particular CVE, and it looks like this particular data. The challenge with this is that likely you're going to want to tune this just a little bit more, because this is helpful and it actually runs in the prompt, but you likely are going to want it to be a little bit more tight on, tell me exactly the name of the exploit and then tell me exactly the name of the CVE. I don't need all the other fluff, because that's only going to slow Bedrock down while it's trying to figure out what we're doing. So in this case, what we're looking at is doing the same workload as that previous Docker container workload, but now we're going to fork part of the process. So remember that when you do application development, it does not have to be waterfall, right? So we don't have to do thing, wait for thing, do thing, wait for thing, do thing, wait for thing, right? We all move to agile, right? So I'm forking a process right off the bat to say, while the API gateway is being built, while the container is starting to get staged, go figure out what this thing is so that I can use that to come back in the lower portion of the step process to inject that just in time, because it does take about 5 seconds for the API gateway to go. So why wait while that's doing that? Fork it off and basically have it start working on that logic. The important part for all of this is that what you are able to do with these techniques is that you're able to start acting like your adversary. You're able to start giving them things that are valuable to them as opposed to guessing what's valuable to them. So I can make just on the fly resources that speak directly to what they're looking for based on, again, that payload threat information. As I alluded to earlier, that also lets me start doing things like metadata analysis about them. So you're a cat. I'm guessing that based on your cat qualities, you're going to want things that include purr. So I'm going to make sure to put a lot of purr in my responses. The idea is that I'm going to try to tailor the output to be more friendly to the actor.
I told you that was cool, huh? It's really cool. All right, there's top 3 lists, top 10 lists. Let's do some top 3 takeaways that I think we really wanted to emphasize today, right? We wanted to be very practical and pragmatic, but this is not an alternative to human expertise. It still takes smart people doing tough challenges and addressing tough challenges to achieve these outcomes. These are tools in the toolbox, as we showed earlier, the screwdriver in the toolbox. And how can we use that to optimize the way we work? Second is, you can basically use these services out of the box. You don't have to necessarily be a machine learning AI specialist. Really, the democratization is what really is this new era that we're in. And being able to take that and then use your proprietary data is where the real value add is. And again, you don't have to be that expert. Start experimenting now. We showed many different ways that you can approach this, many different tools, whether it's in SageMaker, whether it's in Amazon Q, Bedrock. All of these capabilities give you different opportunities, different ways to approach this, different ways to build around it. And if you're not an innate builder, again, look at what's out there that helps accelerate you there as well.
The important part to double click on that is the first one, right? So you saw in both of our examples, right? I think the logical concern is that they're taking our jobs, right? Like that isn't here because in both cases you saw that both Matt and I had to know how to ask the question. So you can't simply say, give firewall secure, right? It has no idea what that means. But it does understand, I need this security group to not have a quad zero-sider, right? So your ability to speak and properly format a prompt is, I think, kind of going to be like the bread and butter for folks going forward, is your ability to interface with these models in a way that gives you the best output.
100%. Well, we really thank you. I know we've reached the end of reInvent Week. Did everybody have a great week? Awesome. Awesome. Amazing announcements, amazing speakers, amazing customers, partners, all of you. We really appreciate you. We appreciate you being in this session, but here with all of us this week. And we really look forward to what comes after this week. What can we do to help you out? And we look forward to your questions. We'll be off stage if anybody wants to come chat after this. And please don't forget to complete the survey. We really do read those. We really do appreciate your feedback, and we want to raise the bar continuously. Thank you.
Thanks, everyone.